Okay, this is the video explanation for FRQ number 7. This is another calculator-enabled question. This is a good question because it talks about velocity and acceleration, which we haven't really done a whole lot of FRQs yet on those topics. So first off, they give us a velocity formula for a particle moving. The particle is at position 2 at time t equals 4. So they tell us that at 4, we already have a position at 2. So letter A says at time t equals 4 is the particle speeding up or slowing down. So to start out, if we want to know if a particle is speeding up or slowing down, I want to know what the velocity and the acceleration are doing. So first thing I'm going to do is find the velocity at that point. So I'm going to find v of t. So I'm going to plug 4 in for t and solve. So I'm going to use my calculator and plug that in. So go ahead and pause it. You can find the answer and then check your work. But that gives us approximately 2.979. So the next thing we want to find is the acceleration. So I need the acceleration formula. Now there's a couple ways we can do this. We have the calculator can do this for us. It can find acceleration because all we have to do is tell it that we want to find the derivative of velocity. So on your main screen, we'll do this with the calculator here. On your main screen, you're going to want to go to an empty calculator, and we want to find the derivative. So I'm going to go to Menu, Calculus, Derivative at a point. We want to use a value of 4. Press OK. So now it's all set up. We want to find the derivative of 1 plus 2 sine of x squared over 2. And we want the decimal. So I think, oh, I'm in degrees. I was going to say that's not the right answer. So we want to check to make sure we're in the right. I don't know, sometimes my calculator switches back and forth, so we want to be careful. I'm going to switch my settings here. So if you don't know how to do this, make sure you go to Document Settings, switch it over to radians. Okay, now I'm in radians. I'm going to pull that back up again. Start over. There we go. So that's the correct answer. Negative 1.164. So I have a positive velocity, but a negative acceleration. So that would have to mean I would be slowing down because they're working against each other. So basically, we have a positive velocity, so we're going in the positive direction, but we're slowing, our acceleration is negative. So the only thing that would make sense is that we're slowing down. But we have to use calculus to explain it, so we would say slowing down because velocity and acceleration are opposite signs, or you could say the velocity is positive and the acceleration is negative. I'm going to say because the velocity at 4 is positive and the acceleration at 4 is negative. And you could write that out using words. You don't have to use symbols. Okay, part B. At time t equals 4, is the particle speeding up or slowing down? Oh, I didn't read that right. Part B, find all times t in the interval from 0 to 3 when the particle changes direction. So when a particle changes direction, basically we want to look at velocity, right? Whenever your particle changes direction, your velocity is going to be changing from positive to negative or negative to positive. So the easiest way to do this would be to look at the graph. So I'm going to go to a graph. I already have a blank one set up. And I'm going to type in the velocity function. So 1 plus 2 sine of x squared divided by 2. And press enter. Now the only times, we got a big crazy graph here, but we're only looking at the times between 0 and 3, the problem says. So if you want, you can just change your window. So you can go to Menu, Window, Zoom, and just do window settings. That's probably the fastest way to do it, and just change it to 0 to 3, and that automatically sets it up in the right spot for us. Okay, so right here on my graph, I have the velocity going from positive to negative. So I got to figure out where that occurs. That would be where your particle changes direction. So I'm going to go to Menu, Analyze the Graph. I want to find a 0. I'm just going to highlight that point, 2.7075. So I'm going to write that down. And I'm going to round 3 places. This is what you can do. So 0.706. And it says justify your answer. So we would say velocity changes from positive to negative at this point. And I don't think they have any labels, so it's not seconds or minutes. So yeah, we're just going to leave it as 2.706. Okay, part C, find the position of the particle at time t equals 0. So if we have velocity, that's the only formula that we know. If we want position, we're going to go backwards by taking the integral. So I want to go from the integral of 1 plus 2 sine of t squared over 2. Even though we have a calculator to do this one, we want to make sure we write down our work so we can get full credit. And the time interval that we're talking about is, at time t equals 0. So there's not much information that we have. So we can't, the problem is that when I go to set up a starting and an ending point, it doesn't really help us out. The only information that they give us is right at the beginning where they say at t equals 4, we have a position at 2. So if I could figure out, I'm going to draw a little map here. 0 to 4, I'm going to put my time frame in. So at 4, we're at a position of 2. If I could find the distance that they went, I could subtract these two numbers. So this is like the total distance minus the ending position. Then I could probably figure out my starting position. So for example, if I start at -1 and I end up at 2, that means I would have had to have traveled a total distance of 3 to get there. So I'm going to go from 0 to 4 and calculate that. I'm going to use my calculator. Go back to a calculator screen. And I'm going to do Menu, Calculus, and I want to do an integral. So I'm going to just type it in, 0 to 4, 1 plus 2 sine of x squared divided by 2 dx. And I get 5.815, so I'm going to write that down. Okay, so what this is saying is that we want a distance of 5.815, but we only ended up at 2. So where would we have started out at? What we're going to have to do is we take our final position, 2, subtract the part that we traveled, and that should tell us our beginning position. So I'm going to just subtract those 2 there. 2 minus 5.815 gives us negative 3.815. So if this makes sense, hopefully, if we start at negative 3.815 and we travel 5.815, that puts us at our final position of 2. So our starting position must have been negative 3.815. Okay, last section, part D. Find the total distance the particle travels from the time 0 to 3. So we're going to do the same thing again. This time they give us the boundaries. So we're going to go from 0 to 3 of our velocity. So 1 plus 2 sine of t squared over 2. Now the problem is they want the total distance traveled. So if you look back at C, we got some negative values because we were talking about position. So we got to think about this. If, let's say you went forward and then you went backward and then forward again and you ended up at 2. So even though you may have ended up at 2, it doesn't really tell you much about like how much distance you traveled, because you could have went forward 10 miles, backward 15 miles, forward 20 miles, and somehow end up at 2, but that doesn't count all the distance that you actually traveled. So what we want to do is make all those negative parts positive. So whenever I want to find my total distance traveled, I want to actually take the absolute value of this. That'll turn all of our negative distances positive and calculate the total distance that we traveled. Now, a shortcut to writing all of this is you could also write this as 0 to 3, absolute value of v of t dt. As long as it's stated what v of t is in the problem, you can skip writing it all out because you're going to use your calculator. Okay, so I'm going to plug that into my calculator. So I'm going to go back to menu, calculus, integral. This time we're going from 0 to 3. I want an absolute value. So absolute value, remember, is this button right by the book here. Oops, you can't really see it with the glare from my lights. So it's that one that's already highlighted. And I'll bring it back down here. Okay, now I'm going to type in 1 plus 2 sine of x squared divided by 2. You want to make sure you're always practicing with your calculator. You don't want to wait till the AP exam to do that and then have to search for buttons. So rounded to 3 places, 5.301. Okay, so that concludes our FRQ number 7.